Let's talk about the multiplicative property of equality with decimals. So the multiplicative property is a fancy way of saying when I have an equal sign and I have an equation, I can think about both sides of that equation as like a balance scale. So let me just draw a little balance scale here. And it's balanced because of the equal sign. And so if I want to multiply or actually divide, it can be either one, something on each side of my balance scale, it will keep everything balanced. That's a funny way of talking about that maybe, but in this case I have 7 times something equals 17.5, and I want to keep thinking about both sides of my equation here, and I want to get x all by itself. That's my primary objective. If I can get x all by itself, then it'll say x equals, and then whatever x equals, that's the answer to my problem here. So in order to get x all by itself, I want to get rid of this 7 right here. It's 7 times x, and the magical thing that we can do whenever it's times is that we can divide by that number and it will cancel out. So every time I see times, I'm going to use division to undo that. The reason being 7 divided by 7 is just 1, and 1 times x is just x. So on this side, I will have x all by itself, and then I'll know what x equals. However, because this has to be balanced out like a balance scale, I can't just divide on this side just because I want to. I can do it if I keep everything fair and equal by doing that to the other side as well. So I'm going to do 17.5 divided by 7 on this side, and then I will have kept everything equal. Okay, now we can deal with that decimal. 17.5 divided by 7 goes like this. I keep that decimal right where it was. I ask myself, how many times does 7 go into 17? Well, 7 times 2 is 14, so that's probably about the biggest thing I can have. I do 7 times 2 is 14. I find out how much is left over by subtracting, and then I'm going to bring down this 5. 7 goes into 35 5 times, and 7 times 5 is 35, so I know I have made this come out equal, and 2.5 is the answer to 17.5 divided by 7. So in this case, x equals 2.5. All right, let's do another one. In this case, I have division. I have 8 on one side of my equal sign, and on the other side of my equal sign I have v divided by 12.8. I want to undo this division, this divided by 12.8, because I want to get v by itself. So in order to undo the 12.8, I can times by that. So the opposite of division is multiplication. The opposite of multiplication is division. And the reason multiplying works in this case, I can think about that as over 1 if I want to, is that I can cancel just like that. These will become 1s, and I will have v all by itself. So we're still thinking about our balance scale. I'm not allowed to just randomly multiply by 12.8 unless I come over to this side and also multiply times 12.8. Now I just need to do the math. 12.8 times 8. That's 64. Carry the 6. 16, 17, 18, 19, 20, 21, 22. Carry a 2. 8 times 1 is 8. 9, 10. And because I have one decimal place right there, 0.8 is 1, I'm going to move my decimal into there and get 102.4 equals v. So my answer, I can flip that around if I want to and just say that v equals 102.4. Let's do one more. If you're great, you can just stop watching this and start working. All right, in this case I have division again. 7.5 equals y divided by 3. In order to undo division, I'm going to times. So if I times by 3, notice that cancels, and I have to times by 3 over here as well. This is going to be a y. 7 times 3 is 21, plus 1 is 22. I have one decimal space, so I'm going to have to move that in like that and get 22.5 equals y. I hope that helps, and let me know if you have more questions.